thank you very much. I feel a little worried that the talk started with a mic drop. So a little worried about that. The topics of interest just means I didn't know what I was talking about as I got on the plane. So I guess the first thing, just, welcome. I'm really honored to come to Brazil. I've never been to South America before, or let alone Brazil. So I'm from Chicago. One thing I wanted to start with, Brian in his talk talked about how they like barbecue in Texas, and I was trying to figure out some way to one-up that. So we like barbecue in Chicago, but we do it a little bit colder and hotter. So this is actually a picture of me barbecuing in minus 25 degrees centigrade in January. So, you might keep this in mind for the later parts of this talk. If it starts to get kind of crazy. This will explain that. Okay. So the thing we're going to talk about is Async I. So this is a comment I heard somewhere recently. It's like Async I is the future of Python. Maybe that's a little bit of an exaggeration. I don't know, but it's an interesting comment. And if you have not used Async I before, here's kind of the background on it. Let's say you needed to write a program that managed, 10,000 concurrent network connections. How would you do that? I mean, it's like, there's a lot of people doing things like that, like WebSockets and lots of connections to things. Is the mic okay, by the way? It sounds like it's cutting out a little bit, but okay. So how would you do that? And if I gave you no information, I mean, this is actually a fairly tricky problem to solve. It's it's like, how would I write a program to do 10,000 concurrent connections? That is what Async I is about. It's like you can do that kind of thing. And to just illustrate that, I thought I would do a little coding with Async I just to show you what it looks like. So what I'm going to do is I'm going to write just a really simple sort of network echo server in Async I. We'll take a look at what it looks like. If you haven't done socket programming, I apologize. I'll say a few things about it. Also, this is my way of offending Pep 8 just from the start of the talk here. So Async I, it's all based internally on sort of event loops. Okay, so what I'm going to do to start is I'm just going to get an event loop. I probably wouldn't do it there in reality, but I need that. And then what you're going to start doing is writing async functions. Now, right away, you might be looking at that saying, async def, what is that? Like, you've never seen that before. Well, you're in Async I. This is new Python 3.5 features. It's so new that my editor does not even know how to indent after that. Okay, so I have to space it over my name. And so what we're going to do is make a socket here. Do a little setup. If you haven't done network programming, by the way, this is actually quite awesome, what I am doing here. Prior to coming to Python, I used to do C programming. I used to do socket programming and C programming. And if you've ever done socket programming in C, you will know that it is not like this. It is way worse than this. And this was actually one of the things that got me into Python programming was just how awesome this actually is. Okay, so what I'm doing here is a little bit of socket programming, setting up a network connection, and this part down here is some code that is waiting for an incoming connection, and already you're starting to see some pretty crazy things. We have an async function here. We have this await operator. It's like, what is that? It's awaiting for a connection. When I get a connection, I'm going to create a task to handle it. Okay, maybe something like that. I'm going to put a print in just so we can see where the connection comes from here. Okay, so this is a little bit about what Async I code looks like. If you've written code that uses threads before, you'll find that it actually looks pretty similar to that. It looks quite, the functions look kind of the same, but I've got these things like these await statements in there, which look a little weird there. Okay, so what I'm going to do here is just read some data off of this socket here. if there's nothing, then we're done. And then I'm just going to echo it back. Again, I'm using this await statement. This looks very odd. Again, if you haven't seen it, and I have a typo in there. I'll fix it in a second. I'm gonna make it print like a little got message on there to just so I can see that it's different there. Okay, so there's a little echo server in Async I. Okay, so barely fits on the screen, but if you've done anything with sort of threads or sockets before, it's very standard looking code. Except it has these async and await statements in there. And let's go ahead and run it here. So what I'm going to do to run this is I have to sort of create a task that's going to getting some lighting effects here. Okay. I'm going to launch a server there, and then I'm just going to tell the server to run forever here. And I think okay, good. Okay. Now, assuming I haven't screwed that up, we're gonna try running it and just see what happens here. Okay, Python 3. Don't even try this if you're not using Python 3. Okay. Okay, so there's the thing running. If it's working, I should be able to connect to that and then type commands. Oh no, okay. Oh, I know what I got. It always helps to spell things correctly. So okay. Okay, let's try it one more time there. Okay. Okay, so what I've got up here is I've got one network connection connected to that. I'm going to go to another window, do the same thing. Excellent. I've got like 2 different windows connected to that server. If I wanted to, I could launch 100 more windows, and it would work with that perfectly well. But this is kind of the idea on Async I/O, is you can write code that looks like it's just sort of normal Python code, but it uses things like the async statement, the await statement. There's a little bit of detail with an event loop, and we'll get to that, but that's what it looks like. I mean, how many people think that's kind of awesome? Actually, I mean, it's an awesome thing that's going on there, and the thing that's really kind of interesting about that is that other people think it's awesome as well. The idea for this async and await, this is not a Python invention. Actually, I don't know who invented it first, but maybe C# is where it showed up first in kind of popular use. So the idea of these async functions and awaits and so forth came from C#. It is coming in JavaScript. There's a lot of interest about that. One of the things with JavaScript worries me a little bit. I don't know this Jake guy. I apologize to Jake, but he wrote about async and await. They're brilliant, and I want the laws changed so that it can marry it. Okay, that's like. Okay, so I don't know Jake. I apologize, Jake. Maybe send me an email. I can help a little bit here. Okay. It's showing up elsewhere. Dart has async and await functions. You have it in Scala. So you have this very interesting thing going on with asynchronous programming, just in programming languages generally right now. It's like, okay, Python is kind of adapting to that. And I find that very exciting, actually. I mean, the idea that Python is going with some of the times and taking good ideas from other places. I think you're even getting it in Fortran. Actually, no. No. I'm not so sure about Fortran. Actually, I put this slide in here mainly because if it ever does get added to Fortran, I want to take credit for having the idea first. So, and also it should have shortened names. So it's just asyn and away. So in Python, you get it as well. This pep 492 is where you find details about it. Not really going to go through that right now. But one thing that I wanted to say about it is it's fun. It's like I've been kind of coding with async and await for a little while, and it's like, this is cool. I mean, it's cool like other features in Python. This is a picture of me with my kids actually go-karting over the summer. I don't know who picked the idea of doing go-karts last night, but that was awesome. So I will say that I beat my kids every time at go-karts. So very, very, very competitive there. So, all right. So this async I/O thing, you look at that and say, is that, I don't know, is that the future of Python? Down here's another quote. In full disclosure, it's a quote about JavaScript. But JavaScript programmers are doing a lot of asynchronous programming. We have somebody here saying it's amazing. It's like the mecca of working with asynchronous code. The fact that they're saying that makes me wonder that maybe Python programmers, if they start using this, would start thinking similar thoughts. I mean, it's kind of an interesting. I don't know. Well, maybe I don't know how much weight to put into JavaScript programmers, but it's an interesting thing. So maybe I don't know. I just think about this. I think it's this is amazing. This async await. I've been programming Python for a long time. I can't even remember the last time new syntax got added to the language. I mean, it's maybe 15 years ago or something. I mean, it's really amazing. Now, one other thing in preparing this talk, while we have a quiet moment here. So coming down here on the flight, I decided my intention was that I was going to sleep. It was like an 11-hour flight from Chicago. It was overnight. Left at like 10 p.m. from Chicago. Comes back. Unfortunately, I did not sleep. I made a very bad choice in my decision on the flight. And my bad choice was to watch Mad Max Fury Road. I don't know, if you have not seen this movie, I think this might be the ultimate perfect movie on software development I think I've ever seen. I mean, it's like completely insane, complete mayhem, and it makes no sense at all. And in some sense, I'm like, wait a minute, this is like async I/O. I mean, we're going to see why in a second. So welcome to the futures, and you get into things. I'm like, oh, it's like the documentation for async I/O, which I can't even tasks and futures and things wrapped with futures and tasks and coroutines, and it's like I think this could be automatically generated by like a Monte Carlo or something. But it's very hard to figure out the docs, the debugging of it. If you ever have to go in there, it's sort of crazy. Actually, one of the things I thought was awesome in the movie is they're like driving around and people are like repairing engines and blowing gas into the turbocharger, like on the hood while they're like fighting and stuff. And I'm like, oh, that's just like debugging. And maybe debugging in production, perhaps, but there's some kind of debugging. And then reading the source code, there's all sorts of crazy stuff in there. I mean, if you want to make somebody cry at a Python job interview, I mean, just ask them what something like this does. A class with an iter method that yields itself and then returns like a result or something. I mean, this is like, actually, this little tiny fragment is the whole key to async I/Os, but figuring out why it's there is not a trivial task. And then I sort of worry about the users of this thing. I mean, and maybe it's my age or something, but I do tend to like to know how things work and how things, what happens under the covers, and it's, if looking at async I/O, it just kind of blows my mind what's going on there. And so I'm struggling with this module. I'm having a lot of like internal struggle. It's like async, fits my head, but maybe not in the right way that I want there. So and then the other thing that really kind of scares me, this is a slide from PyCon Canada that I think was like 3 days ago. I don't know. It's concurrent with the Brasil conference, and somebody put up a slide that just says, I have to understand something before it gets added to Python. This does not bode well for async I/O, because I'm having a really hard time with this module. Just figuring out like what is the role of this module exactly? Because it has tons and tons of things in there, like event loops and transports and protocols and futures and coroutines and tasks wrapping coroutines and threading, and like it just like shatters the mind to look at it. And so I'm in some sense sort of pleading for help on this thing. I understand the big picture of it, concurrency. I understand that. I understand why somebody would want to have 10,000 sockets. But there's certain aspects to this that I just don't quite understand. Like, is it meant to replace Tornado? Or is it something that Tornado is supposed to be built on top of? Or is it is it an API? Is it's and probably more of a selfish interest at the bottom. I worry about how do I actually teach this thing. I don't know whether anybody was in my tutorial on whenever what was that, Saturday or something? I did an Async I tutorial. About half the people ran in horror about like halfway through it, and I struggle with the teaching of this. And so it's a little bit of history on it. I think I don't want to talk bad about Async I without also saying that there's a tremendous amount of history and struggle represented in that module. I mean, we're really talking about maybe like 16 years of Python history and thinking and working through the problem of asynchronous programming. To really kind of understand that history, there have traditionally been sort of two approaches to dealing with that concurrency problem in like networks. One of the things that you could do is do thread programming. You create a bunch of threads and you write sort of normal looking code. The other thing you could do is event polling. At a very low level, you could use something like the select call from the operating system and then start building event loops. And ultimately, things like Async I come from that side of things, event processing. I mean, you have polling leading to things like callback functions, leading to things like deferreds and futures. I'm not going to give examples of these because I just don't want to, but it's like you have callbacks, you have futures, you have deferreds. You have stackless Python, if you've ever encountered that, kind of sitting over in the corner and saying, hey, you should use green threads and things like that. I think stackless, by the way, is probably about 20 years ahead of its time. I know people were talking about that a long time ago, and I don't think it really resonated in people's minds. And what has happened is everyone has been reinventing it. So it's kind of some interesting history. But you have that. You have generators showing up in Python, and you have people thinking about clever tricks with generators, like inline callback functions or inline deferreds, getting into things like coroutines. Again, I'm not going to do some examples in a second, but you have all this stuff kind of building on itself. You have the yield from statement that got added in Python 3.3, and you get Async I and the directions of the arrows that I've put on here are very intentional. Almost all of these things that have been added have been taking async programming and trying to turn it into something that looks sort of like thread programming. I mean, that is really kind of the big, a big appeal of things like coroutines and things, is that you can write code that looks like thread programming. I mean, you can reason about it, you can kind of see what the code does, but you're not using threads. So it's like you're trying to get as close to threads as you can, but not actually use them. I mean, that's kind of the idea. And then all of a sudden you end up shooting over to this async await thing. This is, again, Python 3.5. And I think this is, really, it is kind of a long history. I mean, this is a really complicated problem that's trying to be solved here. I mean, people have been working on this for 15, 16 years. I think it's a really important problem to solve. I mean, if you look at what is going on in all these different programming languages, why are they adding async and await? Well, they wouldn't be doing it if it wasn't an important problem. So, it's an important problem, but it does have this really complicated history, and trying to understand every single piece of that is a very involved process. I've given tutorials at PyCon conferences about generators and coroutines and all these things, and each one of those, it's like a 3-hour tutorial. It gets into like very complicated, like low-level details. It's a lot of smart people that have been working on this problem. So again, I don't want to give the I'm not saying anything about Async I in the sense like, oh, it's bad programming or anything like that. I mean, this is a really hard problem that has been solved. So, but what I do want to do though, is I want to throw out this kind of thought. As a user of this Async I I will admit that I don't really want to think about all that stuff, like callbacks and futures and tasks and coroutines and event loops. It's like, I just don't want to think about it. And I don't get the sense that other people want to think about it either. I mean, if you look at, like, well, the guy who wants to marry async await with JavaScript, I mean, people would not be writing that if they loved event loops or something, right? I mean, it's like there's a lot of people who are very interested in kind of simplifying this, and I think from like the Python side, it's like I like kind of like the go-kart thing. It's like that was fun and cruising around. I don't want to be chased by like zombie warlords or something. It's like I'm just thinking like, is there anything that can be done with this to like not make my head explode? And specifically, I mean, could you take a shortcut to async await? I mean, a lot of history was involved in getting to that async await idea, but could you get there through a different route? So here's the thing we're going to explore. It's like, could async and await just kind of on its own almost be sort of the async future of Python? And it's sort of this idea like, could you maybe make it more of an interface than like a specific implementation of a library? I mean, Async I/O is an implementation of a library. So could you run with the async await thing and not use async I/O? I mean, it's sort of this again. It's kind of an exploratory idea here. So I wanted to play with that a little bit. So we're gonna do a bit of live coding here because we have to. Okay, so what I'm going to do is kind of just deconstruct a little bit about what is going on with async and await. And I'm going to do something completely different than async I/O. Okay, so the first thing we're going to start with is just generator functions. I know there might be some newcomers to Python here, or people haven't been programming with it for a while. Writing generator functions is probably one of the most awesome features in Python. You can write a function that uses this yield statement, and where that kind of originated is as a technique for customizing for loops or customizing iteration. Essentially, you could write a function that would just sort of feed values to a for loop using the yield, and there's a lot of interesting things you can do with that. In later versions of Python, though, newer features got added to that yield. It turns out that you can do things like send in values, and you can throw exceptions and other things. So here's something that's going on in kind of the current version of Python. One of the things that you can do is you can write you can sort of mark a generator function as a coroutine. And in that function, you can use the yield statement to get a result, and you can also produce a value. I'm just going to do something really simple here first, like yield some value, get a result, and I'll print out what the result is here. Okay, so the result is result, and you can just start with that. Okay, so there's your function. Now you can look at that and say, well, what is the magic of the coroutine thing about, the coroutine decorator? What is going on there? Well, what is going on there is it's kind of indicating that you're going to drive this function in a slightly different way. Specifically, it's not meant for loops. It's not meant for iteration. Instead, what you're going to do is if you create this, you'll get a generator object. And what you're meant to do with it is send in values. Like you say send none or something like that. What that will do is it will run the code up until it hits this yield statement, and then it will just pop out whatever the value was. Okay, so you see some value kind of popping out of that. And what's interesting at this point is that the function is suspended. It's like, it's not running at all. This is sort of a key feature of this that these async frameworks are relying on, is that you can have a function suspend. Because what happens is when you're doing network programming, you have to suspend while you wait for network packets to come or input to arrive. So this is what they're relying on. And then if I want to resume the function later, I can just send in a value. Like I could say the value, send in the value 42, and it will come back alive, and it'll say, oh yeah, the result is 42. And the stop iteration, it's a technical detail. It just basically means that the function terminated. Okay, so that whatever happened, it's done. So this is what a coroutine looks like. And the reason that I'm talking about this is that this is what async and await are built on top of. If I write an async function, like I say async def foo, and I'll put in, like, I'm going to put in some print statements here. I can use the await statement on that spam function. Like I can say await spam and say and foo. That is actually the mechanism that enables this new syntax. It's like I have to have a coroutine kind of to work with, and if I work with that, I can start using it with the await statement. Now the thing that's kind of interesting about this is that if I call this function foo, it kind of has the same behavior as the original generator. Like it doesn't actually do anything, but if I send in a value, you'll see it kind of come alive. It says, oh, you're starting foo. Oh, there's the value that came out. The thing is sort of suspended at this point, but then I could send in a value, and it would say, oh, okay, the result is 42, and end foo. It's like you've written like a function that builds upon this generator machinery. I could continue doing that with even more functions like async def bar, and I could say, okay, I'm starting with bar, and then I'm going to await foo and bar. You're going to see these functions, they just sort of stack. They start stacking on top of each other, where if I send in a value, you start seeing kind of the chain of these functions running. It's like, oh, I'm starting bar, I'm starting foo, and then all of a sudden a value pops out. And you send in a result, and you see the thing ending. So there's kind of an underlying machinery that's driving this. It's like async and await. There are some peculiarities of Python syntax, by the way, just as a note. If you just write a normal Python function and you try to use the await statement, that will generate a syntax error. Not allowed. It turns out that the await is only allowed inside of a function that has an async on the front of it. And the same thing actually applies for a function that, like if you declare a function as async, you can't use the yield statement inside of it either. It's like a mutually exclusive thing. Like if you're using async await, Python is trying to kind of separate that out. So this is kind of the underlying machinery. Now, what I'm going to do, I'm doing on time here. I'm going to build a completely different version of Async I/O, just live from scratch here. This is going to maybe blow your mind, assuming it's not blown already here. Okay, so I'm just going to write like a little play.py file here. What I'm going to do in here is I'm going to start by just declaring two coroutines. And these are going to be the dumbest coroutines ever. It's only going to have one statement in it. A yield statement. I'll show you what this does in a second. Okay. I'm going to start with just that. Two functions, something called read wait and something called write wait. One statement, a yield statement. Nothing else. This is maybe the simplest generator function that one could possibly write, except maybe using like a pass statement, right? Okay, so it's very very simple code. What's going to happen with that? Let's just load it up here and try it. If I were to say like f is equal to read wait on I don't know, some socket. I'm not going to do the socket module right now. what you would get is you'd get a generator, and if I tried to send something into it, it would just come back saying, oh, you want to read wait on socket. It's going to tuple that. That's all it does. It does nothing else than that. You can send in a result, but it does nothing. Okay, so that's what we're going to start with. And then what we're going to do is I'm going to recreate the async IO event loop. But at least those high-level functions that were in there. So the functions that were in there was there was like a socket receive function, like that. And well, let's just go do this one. Here's the idea. How would I receive on a socket in like non-blocking mode? Well, what I would do is I would actually just want to wait for something to happen on it. I'm just going to say await, read wait. This is the whole idea. It's like wait for something to happen, and then when it does happen, I'm just going to do it. That's it. That's one function there. I'm going to do the other the accept function here. To accept a connection, I'm going to do the same thing. Just wait for something to happen, and then return a result back. The send all is a little bit tricky. What I'm going to do here is I have to do a little bit of a loop that just says while I have some data to send. I'm going to wait for it to happen. Wait until I can write, and then I'll do a send on it. I'm missing a colon. You're not going to start the colon versus non-colon argument, are you? Isn't there like a special subgroup of Python flame war dedicated to whether the colon is needed or not at the end of the day? Okay. Okay. So don't want to get into that. Okay. So what I'm going to do here is I'm just going in a little loop that basically says, okay, while I have some data, wait until I can send it, and then I'll send what I got, and then one of the problems with send, so you can have partial data, okay, so it's a little bit weird there. Okay, so what I've done here, just as some big picture, I have recreated the 3 functions that I was using in my earlier code. Just to go back to the aecho thing, I have sock accept. Down here, I have sock receive, sock send all. 3 functions. Those are the only three things that I'm using there. Okay, so I've recreated those, and I think it might look a little bit foreign, but the functions are not long. It's essentially wait for something to happen, then do the thing that happens there. Okay, so we're start with that. Now the next thing that we're going to do. Okay, so we're starting with that. The thing we have to do next, though, is that this loop has this notion of creating tasks. These are like these little coroutine things that run. So what I'm going to do is do that now. Okay, I'm going to use something from the collections module here, and the idea that I'm going to use here is I'm just going to make like a list of everything that's ready to run, like make a little ready queue. And what I'm going to do is I'm going to put a function on here that just sort of says create task, where you give me a coroutine, and all I'm going to do is I'm going to append it to the ready queue. Think about like an operating system here. There's like a list of things you want to run, so I'm just going to put it on a queue, and then what I'm going to do is I'm going to write like the run forever method. And all that's going to do is it's essentially just going to say, well, while there's something to run, just get a task. Actually, I'm going to do this. I'm going to say self current task equals self ready pop left. And then what I'm going to do is I'm just going to run it using like a generator. Okay, run to the yield. Okay, so I'm gonna do that. It's just pulling something off a task. It's using the send to run it, and then I'm gonna stop. Got a little loop there. This is actually kind of the core of these event loops, by the way. It's like you take things and you want to run it. You just do a little cycle like that. The only other thing that I need here, though, is I need some way to deal with I/O, and this is the part that is potentially going to kind of shatter your minds. I'm going to code it and I'll try to explain it. But if it's just wild, don't worry about it here. What I'm going to do in the rest of this code is I'm going to do a little magic trick using a module called the selectors module. This is actually the core of Async I/O. It's a way of watching sockets. So what I'm going to do on this loop is I'm going to make a little selector here. Going to make a selector, and I'm going to write sort of two different functions that interact with that. I'm going to write something called readWait, where you give me a socket, and all that's going to happen here is this thing is going to register an interest in that. And it's going to basically say, what's going on here is this is saying the current task is interested in reading on that socket. I'm going to do a similar one that does it for write. These are one-line functions, by the way. So I have two methods here that are just sort of saying, okay, the current task, it's either interested in reading or it's interested in writing. And it's kind of registering its interest with this little selector thing. What is going to happen with those is this. If you look at these yield statements that I have here, I'm yielding a name along with a socket. Here's the neat little trick that I'm going to do. I'm going to change this operation here to just sort of unpack those values off a generator. And then I'm just going to look it up as a method on myself. And then I'm going to call it as a function. This is kind of a sneaky method call, okay, that's going on there. Okay, so sneaky little method call. What that's going to do is call those functions. We'll see how this works here in a second. And then we're basically almost done. The last thing that I have to do is I have to modify this loop a little bit to poll for I/O. So what I'm doing here is I'm saying, okay, if there's nothing ready to run, go get all of the I/O event. Okay, so this is a little bit of tricky stuff that's going on in here. Just as a note, this is way less tricky than what is actually going on Async I/O. So if this is, we'll look at that. So what I've got here is just a little loop, few small functions that are doing I/O and so forth. This is a completely different technique than Async I/O is using. But now here's the question that comes up. Could I just plug that into this code that I just wrote? I mean, I just wrote this async I/O code. Could I just get rid of async I/O? I'm gonna put this into a file like p-echo. This is my play echo here. I'm just gonna get rid of that, and I'm gonna import that play module that I made. And instead of the async I/O event loop, I'm just gonna make my own loop. I'm not gonna change any other part of the code. I use the same function names. I haven't changed anything about that. Here's the question that comes up: is that going to actually work? I don't know whether I'm a betting person, having made no typos in that. Well, let's whether I made no typos. Well, let's run it and see if it actually works. Okay, so this thing is running. Okay, looks like it's responding. I can't believe that worked on the first try there. Okay, so two concurrent connections there. both at the same time. It is not using any part of async I/O. It's like it's kind of like doing a totally different thing. I think that is a very interesting kind of idea, and it kind of gets back to this idea that maybe async could be an interface. Maybe it doesn't have to be a library. Maybe it could be an interface purely based on the async and the await syntax. And so, you get this question. It's like, could that be something that would be interesting? It's like an independent async API. I think it could be possible. I mean, especially if you fully embrace the async and await syntax. It's like if you have some kind of layer where it's like, oh yeah, we do async and await. We don't care what's going on underneath. We just want to use that. You could have some interesting things happening. There is some historical precedence for this kind of thing. Python does have standardized APIs for things like WSGI, the database API. I mean, there's probably some others that I've missed, but there's people have done this. I also think this is a really highly interesting problem. If you're interested in kind of interesting project to work on, what is the design of an asynchronous API? I think this is actually a really tricky problem. Like what needs to have an await on it? What does not need an await? What is like the consistency in the interface? I mean, you like I don't know, like here's something to think about. Let's say you have a bunch of methods, some of which have an await, and some of which don't have an await. How much confusion does that cause to a user of it? Like, do you have to like how much mental knowledge do you need to remember? Oh, that one needs an await. This one doesn't need an await. That is really tricky. That also takes you into a whole different argument, like the creators of G-Event do not like this await and async stuff because it's like complicates things, and like one thing in that package is you get asynchronous programming without having to do this kind of thing. And I don't know whether I want to go further in that direction, but that's a really interesting problem. You get into these things like how many interconnections between the parts are you allowed to have? I mean, how simple is this thing supposed to be? Async I/O, as it is right now, is actually a very complicated library with kind of a very big API. I don't know whether that should be this API. I don't know. I mean, that's a tricky question. I have a feeling that if you could do this, it would actually be better for Python. If you focus on APIs, it encourages people to play with ideas. It's like, could we experiment with different implementations of async I/O? Could we think about that sort of thing? Or maybe could somebody do performance experiments with it? Actually, just as an example of that, I did write a little benchmarking script. All this does is it just sends 100,000 messages to this echo server and just times, like, how long does it take? How fast is it? So I've got my little echo server running there. Let's just run it and see what it comes up. It's going to run for maybe 5 or 6 seconds, and it's what it's doing is sending 100,000 very fast echo requests, and then it's going to tell me how long it took. Okay, so it comes up and says, 10,000 requests, 10,000 messages per second. It's not too bad considering just kind of hacked that code live at the podium here. I mean, it's like 10,000 requests a second. Let's try it again with async I/O. I'm going to go back to this is my async I/O version of the code, and then let's try that benchmark over here. Let's just see like how we did here. Again, keep in mind the code is basically identical except for that just replacement of the event loop. It's not bad. I mean, it's like 30% faster. Just hacked right here. You could this is the kind of stuff to think about. There's a lot of clever people kind of floating around in the Python world. It's like, what if you what if you sort of launched like the PyPy guys or something like that on this kind of problem? What would they be able to do? And like I could even do some tweaks here. I'm going to make one little tiny change to the code here, where I just interchange the order of the sends. What I'm going to do here is try to do the send first, and then catch an exception. This is some non-blocking I/O kind of stuff going on there. So I've just kind of rearranged the code. I don't even know how many lines of, like how many change, that wasn't even much of a change at all. All I'm going to do there is, I changed the code. Let's run my benchmark again and see what happens. 14,000 messages a second. I mean, so I'm almost 100% faster than async I/O at that point. If you're sort of curious about that, it's like, wow, that's kind of interesting. I actually wrote an echo server in G-Event. This is actually straight from their documentation, by the way. So it's like, I mean, G-Event is a very popular library. We could look at that. We could say, well, how are we doing against that? That's a library that's been around for a while. Let's see how my oh, I don't have it on Python 3. That's okay. So we're gonna do G-Event on Python 2.7 versus this hacked sort of play thing that I just did here live, and we're just gonna see what does that do. Okay, so it's faster. But I'm amazed that I'm even able to get that close to G-Event. I mean, G-Event involves C extensions and a whole bunch of other magic going on. So this is the kind of stuff I think you can think about, where it's like, if this is more of an API, there's a lot of interesting things that could be done, like experimentation with different implementations, like performance tuning. I think there could be some more interesting interoperability stuff, like. Why does Twisted have to run on async I/O? Couldn't Twisted just implement an API and then just run on that? I mean, that's like a different. It's like I'm not thinking about a layer so much. I'm just thinking about an API. So kind of leaving you with. I'm going to be in so much trouble because I'm getting on. I have this slide now. I'm going to get on a plane and who knows what's going to happen. I sort of wonder whether async I/O could just be, maybe that was part of the route of getting us to this point. Maybe it was a very important piece of work in figuring out the problem, but could you do something else? There is this note in the async documentation that it's provisional and that it could even be removed. Maybe it should be removed. I'm going to be very unpopular after this talk. Okay, so that's kind of the end of this. End of this talk. As far as a takeaway on it, I don't know what the take. I guess the takeaway is a lot of this stuff in Python can be. I think it's okay to rethink some of these things. Even things in the standard library. It's not necessarily set in stone. I think it's okay to challenge these things, and I think this async programming thing is really an example of that. I mean, it's a really hard problem. It's got tons and tons of history behind it. And you can ask this question, it's do we have to keep all the history? Or once you discover something really new and interesting, could you just run with that and take it in a whole different direction? I don't know. But it's just a couple of comments. I do want to thank my friend Yargo in Chicago. I have to thank him because he might show people my private Twitter messages to him, in which I have a tremendous amount of cursing about async I/O over the last 2 months. I've been talking with him a lot about design. It's this is really hard, the design of this stuff. I also want to, just thank the PyCon Brasil people for having me down here. I mean, I've had a really great time at the conference, and I thank everybody, that came to tutorials and stuff. Just really thanks for that. So I can ask them some questions or go run and hide, depending on whether there's any core developers in the room or not. So. Okay.
Hi. Have you tried to speak with the core team about this different implementation?
Have I tried using this? I have written a library that's using it. Right now it's very experimental thing. I mean, it's a question of have I used coroutines before?
But,
or just
they,
this.
They discuss the PAP in open emails. Have you tried to expose your ideas to them?
Not really directly. I mean, I've done a lot of like teaching and tutorials and things on this. So you're thinking like the mailing list for Async I, I haven't really approached them with that, but it's partly maybe like a time thing. I mean, like honestly, like this thought of like this API thing is actually something that's very recent in my mind. And maybe this talk in some sense is actually the first kind of formulation of it. In some sense, it's almost like it's like just been kind of sitting, in I don't know, in my gut or something. Or it's like, there's just something off about Async I. I can't quite put my finger on what it is. And so yeah, I don't know. They'll probably find out about this, and I'll be in trouble or something.
That's because you talk here, not there.
I have to talk about it here because it's safe distance.
Thank you.
Okay.
Hello, it was a really nice speech. Talk was very nice, and I have a question. You have some ideas of what asyncio, asynchronous practice should be and what it should not be. Do you have an implementation that you think it has a good design, it's something that the core developers of Python should look upon, they should get inspiration from?
Well, okay, so I do have an implementation of something I've been working on. I kind of told myself I was not going to talk about it in this talk, so I'm not even sure I'm really going to mention it. I do think there's like some. I do think there's like some qualities of what I would like to see in a good implementation. I mean, one of the qualities that I would like to see is fewer interconnections between pieces. One of the things in Async I/O is that it feels like there's a lot of like tight coupling between different concepts. Like they have this notion of protocols and they have this notion of transports and loops and a lot of the objects are very strongly kind of linked together in the implementation. I think that you might be able to break some of those links if you were to sort of think about it in a slightly different way. I mean, I don't know whether that idea is like really well formed in my mind, but and I don't even know whether that answers your question, but it's like there's certain things like that sort of think about. It's like, does it have to be so tightly linked, or does the API have to be so big? Could it be a smaller API that does this? I don't know. I think this is a super interesting problem for somebody that likes to think about APIs. I mean, I'm not even sure that I'm the best person for that. I mean, yeah.
Thank you.
Okay.
I have two quick questions. Where does asyncio weight come from? For I know several of the concurrent features of Python was borrowed for SSP games by the implementation Screencast Python. In this version, where it come from?
Like, where did async and await come from?
Yes.
I think probably, well, I don't know the full history of that. I think maybe the Python developers were looking at C#, like because they were used in some other languages. Yeah, I don't know the full history of that, but certainly I think C# is probably the big language where it showed up first. I think also on the history, I think kind of the motivation for it is that the alternative to await was the yield from statement. It kind of looked a little weird. Like, I mean, if you wrote a lot of code using Async I/O, it was completely filled with sort of these yield from statements everywhere. And in some sense, the syntax it's kind of there to maybe make it a little bit more clear about what your intention with that code is or what you're doing, because yield from could be used for other things besides this. And so, I think that's some of the motivation on it.
What's the version of Python you use? Python 3.4.5 methods to grade with this library.
You need 3.5 to use the async in a way.
This is not in 3.4.
It is not in 3.4. If you're in 3.4, you would have to use yield from. I realize that selling 3.5 on people might be a little Is Red Hat shipping 3.5 yet? Probably not. I mean, this is, you know, you're sort of way out on the on kind of the bleeding edge here, but it's.
3.5 is the new Shopify. It's way better than the previous version.
Well, I don't know whether it's way better, but it is way different. So.
Thanks.
I like it, but it's very different.
Thanks.
Okay.
Hello, David. Thanks for your talk, amazing. I have a quick comment and a question. I think we can learn about a lot about concurrency studying the virtual machine, because they do it very optimized in a very optimized way for 30 years, you know. And the question is, what about uploading this live created module to PyCon so we can hack on it and try?
I'll put it. You know, yeah, okay. Actually, the coding style that I did here, I didn't want to mention it, but you know, I do have this library online called Curio. And this is the technique that is used in that, although I've expanded it more in different directions. But yeah, it's online. I'll put the talk code online too. So. All right, I think is that it? Is that it? Okay. Well, thank you very much. I had a great